Hello, my dear friends. Welcome you all. In this session, we are going to study about this application of pure substance. By this application of pure substance, we can easily calculate any refrigeration and air conditioning problem under vapor compression refrigeration system. So let's start. So my dear friends, in this session, first of all, we have to plot our graph over TS scale. This is your T and this is your S scale. Okay, this is your T scale and this is your S scale. And now we have to draw a saturation curve. Okay, now we are going to plot our this VC cycle. Okay, so this is our process number 4 to 1. This is our point number 4. This is our point number first, and this is our process 1 to second. That means compressor process. And now from this superheated zone to our saturation curve, and again plot our condenser heat exchange. This is this is our throttle process from point third to point fourth, which is highly irreversible process. Here also some heat losses are occur. Also some heat losses are occur. Okay, right? This is our QE effect. That means refrigeration effect. Is it right? And this is our QR. That means heat rejection occur from here. And this is our work input over compressor. Okay, fine. Now this is our cycle in anti-clockwise direction. Is it right now? Where our refrigerant gonna be flow in this anti-clockwise manner. Okay, fine. Now again show your temperature zone. This is your higher temperature TH and this is your T lower temperature, from where temperature gonna be extracted from this storage space and temperature gonna be rejected to the ambient. Okay, to the ambient, that means T in infinity or T higher. Okay, right. Now let us point out, or all let us figure out all the points with respect to in mathematical form. Okay, so at point first, here S1 gonna be represented as SG. That means because this line is your gases line. Okay, so at that point over this line, S1 is represented as SG. Okay, fine. And here what is the value of S2? The value of S2 is nothing but SG. That means this point, from this point SG plus this specific zone. That means CP for the vapor, and in bracket ln T2 by T2 at that point temperature, T2 by T saturation. Is it clear? And if this point number second is gonna be show with respect to H enthalpy terms, then H2 is nothing but H2 equal to Hg plus Cp V in bracket T2 minus T saturation. Is it right? Now, and again in enthalpy terms, H1 is shown as Hg. Is it right? So these are the mathematical representation by the help of thermodynamics. Okay, and here you can also show this point number third as H S3 equal to SF, that means in liquid form, or if we want to show this point number third as in terms of enthalpy, then S3 is represented as HF. Is it right? So these are the representation. Okay, these are the representation. These are the thermodynamic equation, and these are the representation of various point number first, point number second, and point number third. These are the mathematical representation by which we can solve any question under this VCRS system. Okay, fine. So my dear friends, this equation is very helpful to calculate any problem. Okay, my dear friends. So in next lecture we will study over what is the difference between dry compression and wet compression under our compressor. Is it clear na? Under our compressor, what is the difference between dry compressor and what is the difference between wet compression? So here in next lecture we will study the difference between dry compression and wet compression. Okay, my dear friends. So thank you